Hello from Romania. There it is, 5 volts, 300 milliamps, and you can hear it. Come on, you are clicking, so yes, like that. I want to hear you. So what all this complication that we have here means? I just got quiet. Like that. It means that I wanted to drive a stepper motor. Actually, multiple stepper motors. This is a scrapped from garbage a stepper motor with 4 wires. This is a brand new, recently buy. It's having also a very stupid long wire, very long wire. Probably it's this long for CNCs, most probably, when this is on the other side of the rail or something. And this is brand new, also stepper motor with 4 wires. And this is also a scrapped motor, pretty similar to this one, probably from the same device that I scrapped them. But this the difference is that it's having 5 wires, and I had to make a special input plug here. Specifically for it. So I have here 3 ports, motor ports. This port here with specific wiring for this scrapped motor. This black port here is specifically for the new ones here. And I have to take it out, this one, and plug that in. And there is another one here, another port here, in which I'm plugging this in it, and of course taking out the rest and leaving only one of them. So I have with specific permutations, specific wiring combinations for each of them, because if I'm plugging this motor here, it will go up to 500 milliamps, which is not good. And in other cases, I even got 1 amp. And one of my friends from the forums also got it. And this circuit that I have here is not working, but it's not about it. I will change the speed. This is right now is working very slow, as you can see. And you can see it as well, very slow. And now I'm switching it very fast to do it. Let's see, like this. And it's vibrating, trembling. And okay. I want to hear it. Anyway, but this is a history. There is a history behind everything that I made here. So this is the first circuit that I made, a 555 4017 IC. These are the 4 LEDs that you see there, and pretty much this circuit remained everywhere on all the other circuits I made. Only the controlling circuit I changed here. So, and this was the first one. I put directly, as you can see, without even thinking on putting a resistor on the base of the transistors. I just put 5 volts directly on those bases. But guess what? No transistor burned. I think no, one burned out. And also it burned a 555 and a 4017. I think I have here the burned ones. Here, there. Yeah, 4017. This guy here is burned. This guy is burned as well. 555, 2 555 actually. I have burned on 2 possible transistors. I didn't check them yet. I have to check them to be sure that they are burned. This circuit rotated this 2 4 wires motors and 1 5 wire motor. But the difference is it worked absolutely perfectly for these 2 4 wires motors at 5 volts, exactly as you can see it there. At 5 volts, nothing overheated. Worked out absolutely perfectly. The rotation was fine for both of them. This is actually light current, light speed, light power than this. This is more stronger than this because this one is brand new and this is scrapped. God knows where it's scrapped from, and it's a bit weaker, but also a bit more sensitive. If I'm plugging right now this motor here, you will not see the same trembling as high as this guy is doing it. So this is very good for showing how the circuit is working. Pretty much, it's more sensitive, this guy. So where I was at the burning, the burning components. They didn't burn at all at 5 volts for these 2 guys. But when I tried to put this 5 wire. That guy didn't work until I reached 15 volts, not 5, but 15 volts. Actually 12 volts, over 12 volts, up to 15, up to 20, up to 24 even. I got to 24 volts, and at 24 volts, this guy was starting to heat up. So I lowered down the voltage to about 15 or 16 volts, and there it wasn't heating up. But I didn't pay attention to the components and how hot they got. I couldn't even smell them. And when I was changing the speed from this potentiometer, then I got the problems. I burned the chips and probably the transistors as well immediately after I switched the speed here. But so at high voltage, this circuit is burning the components pretty much. But at 5 volts, it says there. No, yeah, that's the plus 12 volts. That is minimum for the 5 wires. But at 5 volts, it worked absolutely fine. Without even a resistor on the bases of those transistors, it worked fine. Of course, it's not safe, and I didn't really think about it, because this circuit I made it in the simulator first. I printed on the paper, I put it here, and I blindly follow it without thinking at anything. And then I realized, hope I don't have any kind of protection here. So that's why, and I was scratching my brains and thinking why those chips burned and possibly those transistors. And then I realized I don't have protection. And then I made the second version, which includes everything that you can see here, even this voltage regulator that is having awesome pins here. And so this, it says here version 1, this was the version 1, you've seen it, and this is version 2 there, which basically I put as much protection as I could think of. Bridge rectifier, which are those, where is my trusty knife, that is not making shorts. So I'm putting my knife directly on this pin, on this chip, and this is a bridge rectifier, and that one as well there. And so I have bridge rectifier. I also have these 4 diodes, which are those there. You can see them. 1N4148. This guy here. I didn't include. I played a little bit with this one. It did give me in the simulation. It did give me a bit of a better rendezvous, but not really. In reality, it didn't show. And then the LM370. Actually, originally I put. Let me show you. I put this IMS 1117. I don't think you can read it, but I put some legs on it. You see, and what happened on the first circuit, actually on this circuit here, I didn't include that voltage regulator here. That was a mistake here in the first version, and I corrected it by including it in the second version. And but in the first version I had that IMS 1117 voltage regulator, and I imagined what could have damaged the circuit, from where the high voltage or high current could come from. And I realized that that IMS 1117 was probably the current and voltage come over it, overwhelming it, and coming to the 555 and burning the 555s, or somehow from the bases of the transistor, somehow coming back from the spikes of the motor, or something. From one side or from the other side, the high voltage should have come when it was at 20-ish volts or 15 volts, whatever voltage it was. But it was much more greater than 5 volts. That's the case. And that IMS 1117 is a voltage regulator is up to 15 volts maximum. Also, this 4017 is also up to, and 555 is to 16 volts. So I was way over the voltage limits for all of this. But it worked. It worked for a long time, actually. It didn't took me like 1 millisecond. I turned it to 20 volts and that's it. No. I spent like probably 1 hour or so, or maybe more than 1 hour, until when I switched here, and I played a lot with this circuit until it burned. I played very unsafely, extremely unsafely. So this was pretty strong circuit from this point of view. Then I switched to this one, which is including a lot more protection. Like I said, I mentioned those diodes there, these 4 diodes here. They certainly, nothing will pass if it's coming from there. Like I imagined, it could be some high spikes or high voltages. It could not pass over there. And here I put this ASD, electrostatic discharge protection. It's a simple diode that is reversed there. Not much protection here, but the only difference from the first one was that I actually included the LM317, which is this one, also with a heatsink and also big legs to actually grab it, and because it didn't fit there. That's why I put such long legs. But this circuit here did a little bit less rendezvous than this one, in the sense that the motors were running a bit slower and the power was a bit less through all of this. And I wanted and this guy almost worked. It kind of worked, but not really, like in the original circuit. Actually, I'll leave this here because everything that you see here, and then, so the problem is driving the motor, the coils of the motor, through all these transistors here. So what I did here, and somebody helped me with this circuit. This is not my circuit. This is from somewhere else, from England actually, and from a lady electronist. And this is a very classic circuit. I've seen it before. It's not a new thing for me. That's why I kind of remember it. And I said, well, I'll try it. So what you see here is only for one. Is replacing one transistor there. So actually not one side, this side here. So this is a PNP and this is a NPN here. So top it will be a PNP group, and the bottom will be a NPN. And this is what you are seeing here. Here is the PNPs, and here is the NPNs. Of course, this is for this, and this is for this. I was imagining I will have one on the left and another on the right here, but it didn't work. So I had to put them one on top of the other, and pretty much it got extremely complicated very fast. And the difference from this very complicated transistorized circuit here, driving, coil driving circuit, the difference from this to this is that all the heat, all the power is distributed on this high power transistors. Even now is burning, is probably 100 degrees or something on this side. And everything that I have here is extremely low powered and extremely So they only vibrate, even that one, but it's so diminished power. All the power is taken by these transistors here on top and not transmitted forward to the actual motors. And it's a way more safer circuit right now, but not working, unfortunately. That's the conclusion, and that's what I wanted to show and to tell you. And I can smell a little bit of hot iron from those transistors there. Hopefully those are not others. And yes, the motor is cold as ice, not overwhelmed at all. And let me focus on the circuit itself, like that, for you to see it, if you really need it. Let me focus on this guy. Very cool circuit with the NOT gates. Very, very cool. I really like it. Now the conclusion, what I will try, version 3 after this. Actually, this is version 3 with version 4. The next one, I will probably get back to this very brute, extremely brute force version 1 with a couple of safety. I will have to play a little bit with the safety of it and see what is working, what is not working, and what is giving me the maximum rendezvous possible, and put some more powerful transistor probably, or in parallel, a couple of transistors in parallel. So if this was only one transistor here, then I will put two in parallel, driving the same wires here. I remember something in this the first circuit, this one and this one. This bottom transistor got hot, but in the current circuit that I have here with a lot of transistors, the top transistors, the PNPs that are right now, but I'm showing it here, the top line is getting extremely hot. So, but also on the left side here, everything on the left side. The right side is kind of cold and protected all the time, but only the left side was overheating a lot. So that's interesting observation, and that's the idea that I will try next to make it work. And also this was with only NPNs, this one and this one. So all of those transistors are NPNs. The new one, the one that we have here, is using PNPs. But in my impression, doesn't really matter what kind of is kind of mattering, but it can work with the same category up to a point. If you take care of the power dissipation, the heat dissipation, and the power, it can work with anything pretty much, even with relays if you put their relays, but it will not be very fast. But I was considering some relays to drive, but I was thinking of it. Yeah, so pretty much I believe I covered everything. We will see. I'm very curious how this. I'm also expecting a specialized. Only this part will be only the coil driver, not the logic driver. This is the logic driver that right now is having no problem because it's very well protected. But this coil driver that I have, I'm expecting a LC294 or something, a chip with a lot of pins on it. Very unusual looking, and it's specific for driving stepper motors pretty much. And I took 10 of them for $7 or something. It was kind of expensive, but yeah, 7 or 9, I don't know. Pretty much this is it. We will see until those chips will arrive, those drivers. I'll try my best to make it with the transistors. And this is actually written here which one it is. 298, I suppose. I don't see. Yeah. L298 is called that chip that is coming. And this is the schematic from inside that datasheet of that chip. I use it motamo specifically from there, and I incorporated and I use it here. Yes, this is it. Thank you very much for watching. I hope you like it, and we'll see you next time. Bye bye. See you later, alligator.